Hello, Workplace Math 10 students. Hope you're all doing well still. This video is designed to walk you through the Chapter 7 test review. So let's get started. So in your Google Classroom, you're going to want to click on your the form that I've included in this assignment, and you should see a test review just like the test. So this is basically in preparation for the test. So you're going to have 18 questions, just like you're going to see on the test. The only difference is that on the test, there will be 6 of these questions that will actually just be short answers that you have to put the answer in at, as opposed to multiple choice questions. But the type of question that you're going to see is very, very similar to what you have here. At the end of this test, what I'd like you to see you do is submit it. And then if you click View Score, you should be able to see which questions you got wrong. And then there should actually be some feedback that lets you know specifically how you would have arrived at the right answer. So let's just get started. So obviously you're going to put your name in here. You're going to go down and start determining the answers to each of these questions. So in this first question, what you're going to be using, because we know 2 side lengths, what we can use in this case is Pythagoras theorem. And because one of the side lengths is the hypotenuse, or when we're talking about a squared plus b squared, what we're in essence saying is that we know c squared. So we have a squared plus, and I'll call 30 here b squared. So I have a squared plus b squared equals the hypotenuse, which is c squared. So what we need to do here is that this number here, the x, is really going to be the smaller side. It's going to be smaller than the hypotenuse. So what we end up having to do to figure out x is we have to take 34 squared minus 30 squared, and then we're going to end up with x squared. And then obviously we're going to take the square root of all of that to figure out the value. So basically, once we take the difference of that, we would have to take that square root to find that out. So let's take a look at how we would use the calculator to do that. So using my calculator, what I would end up with is I would go 34, and then I can use my square button, and then I can just simply subtract off the 30 squared, and then if I hit equals, this is the difference, 256, and if I take the square root, so use the square root button, then the answer is 16. So therefore, if I come back in here and click on 16, that would be the correct answer for that question. So same idea here with this question. This is, once again, a Pythagoras theorem question because we have 2 sides. And once again, we do know, excuse me, the hypotenuse. So what we're going to have to do is we're going to have to take 35 squared, and we're going to have to subtract off the 21 squared to arrive at the x squared that we are looking for. So, excuse me, if I were to go to my calculator here and clear this off, if I take 35 squared and then subtract off 21 squared, I'm going to end up with this value here. I need to take the square root of it, which is 28, and that would be my value. So if I were to come back here, I would end up putting 28 as my answer for that question. Now, when we get to this question here, we are looking at now, same thing, a Pythagoras theorem question, but we don't know what the hypotenuse is. So what we have here is we have 36 squared is kind of like an A side, if you want to say it, and we have the 15 squared is like the B side, and those 2 collectively added together are going to make the hypotenuse squared. So in essence then, what we're going to do here is we are going to, instead of subtracting, we are going to be adding these 2 values this time, because the collective total of these 2 needs to be bigger than any one of those totals so that the hypotenuse is going to be longer. So if this value 39 were not longer than the other 2 sides, 36 and 15, then we would have known we'd done something wrong, but in this case it is longer, so this looks correct. So I'm going to just come back here and choose the value, the correct value, which is 39. And I'll scroll down to the next question. So these ones here are, this question here is looking at Pythagoras theorem, but looking at it from the context of knowing which value or which one of these is a right angle triangle. So in other words, part of Pythagoras theorem requires that there be a right angle triangle for it to work. So now how do we know which one is the right angle? Well, obviously, in this case, whatever one is the longest side is the one that is going to be the hypotenuse, the one that is opposite. But we don't know for sure which one of these is the hypotenuse. This one for sure is not, because we don't even have a longer side. So we're really just looking at these two. So what we want to do is, in this one, we would want to see whether 31 squared plus 16 squared, and then add those two up and then take the square root and find out whether that is 34. And likewise, this one here, we would go 12 squared and 5 squared. And my mouse is not reacting properly here. Let me just give a second. 12 squared plus 5 squared. So basically, we want to find out whether that's going to add up to that 13 squared. And if that's the case, then that would be the right angle triangle. So let's just take a look, plug in these values into our calculator and see what happens here. So, and the first example, we know that B is wrong, but in the other example, we can try this one. So we could go 31 squared plus 16 squared. And then we take the total of that, and if we take the square root, this should add up to exactly 34, but it does not. So this means that this was not a right angle triangle. Now let's take a look at angle triangle C. So triangle C means that we need to take the two side lengths, the two legs, 12 squared and 5 squared. And if these two collectively add up to something that when we take the square root gives us 13, which it does, then that means that that must have been a right angle triangle. So if I come back here then, so the answer to this would be answer C, because this is the only one that was the right angle triangle. So I click C, and that would be the correct answer. So one more example of this. So let's take a look at this one here as well. So once again, this one cannot be right because it's got no longest side. But this one and this one are potential. So we'd have to take the 40 squared plus 9 squared and see whether that, when it adds up and then take the square root, comes to 41. And likewise over here, we would do 23 squared. So we're taking the two shorter lengths, 23 squared and 10 squared, to see whether that's going to add up to 23 squared. So let's take a look at what that looks like when we put that into the calculator. So for, I'll do B first. If we go 23 squared plus 10 squared, and then take the square root, we should end up with a value of 26, but we don't. We get 25.07, so that's obviously not the right answer. But let's try a triangle A. So this one, we're going to take 40 squared plus 9 squared. And then we take the square root of that, and that does arrive exactly at 41. So that is the correct answer. So the answer to this is triangle A. So I'm going to just switch back here, and I would say that triangle A is the correct answer here. So let's take a look now. So now we have done 5 questions, and those were all relating to Pythagoras. So that's the A squared plus B squared equals C squared. And now what we're at here is we are at looking at trigonometry. And trigonometry, once again, is a situation where we don't know two side lengths, but rather we know one side length and an angle, something like that, or we want to know an angle from two side lengths. But this is an easier question itself, and this is just asking what the opposite side is to the angle. So if we're identifying the different sides, what we always have to do is the right angle is the hypotenuse, but then the angle that's directly opposite of theta, that's the angle that we are given, is the opposite. And then the other angle that is left over is the adjacent. So when we ask what is the opposite side to the angle theta, then the opposite side is this over here, which is BC. So the answer to this is going to simply be BC. And so I'll just erase that off here. There was really no calculations to do for this one, but hopefully you can see that that is the answer for this particular question. Now, looking at this here, what we want to know is what is the adjacent side to angle theta now? And so this is the same idea. We need to look here and identify what each side is. So once again, the easiest one is always the right angle. Opposite the right angle is the hypotenuse. Opposite the angle theta is opposite. And then the leftover angle is the adjacent. And so in this case, BC once again is going to be the answer to this. So we would be putting in as our answer BC here. And that would be the adjacent. Hopefully that makes sense to you. Now, question 8, what we need to do here is we need to use the sine ratio to find the unknown side length. Now, we are told that we need to use a sine ratio, but really we should be able to figure that out ourselves. But for a few of the questions, we are sort of given this information. So what we can see here, though, is we have the hypotenuse here. This is directly opposite the right angle. Directly opposite the angle we know is the opposite, and yes, so therefore sine, which is SOHCAHTOA, opposite over hypotenuse, right? We're going to use a sine function, and so what we have here is basically we have sine of 47 degrees is going to be equal to, and we have opposite, which we don't know, so I'll call that E, over 7. And so in order to get E by itself, we just simply need to multiply both sides by 7. And so then we're going to end up having the 7's cancel out here, and we'll know what E is. And we just need to simply go sine of 47 times 7 to figure out the answer. So if I plug this into my calculator, so if I plug that into my calculator, what I'm going to need to do is I'm going to need to take 47 sine, which is going to be a number less than 1, and then I'm going to multiply by 7, which is the hypotenuse. Now, this makes sense because basically the hypotenuse has to be longer than the opposite side, and 5.11 or 5.12 is in fact opposite, or is in fact smaller than 7. So the answer here would be rounded to 2 decimal places, 5.12. And so if I were to come in here, I would be choosing this answer here as my correct answer. Now the next question is telling us that we're going to use the cosine, but once again we can figure that out ourselves by knowing that this is the hypotenuse, and knowing that even though this is the opposite over here, that the actual side length that we know is the adjacent. So we know the adjacent, and we want to know the hypotenuse. So basically when I write this up, we're going to be dealing with cosine, which says ka. So adjacent over hypotenuse, we use cosine. That's why we're going to use the cosine function. So cosine of 52 degrees is going to be equal to, and in this case, it's going to be 3 over A, because A is the hypotenuse. Now in this case, this is a little trickier, because to get A by itself, what we have to do is we would have to multiply both sides by A. So I have my A over there now, but I really want to get A by itself. So right now I have 3 over here, and I have cosine of 52 over here. So to get this by itself, what I'm going to need to do is I'm going to need to subtract the cosine of 52 from each side. And so what this ends up looking like is it's going to end up looking like when I subtract cosine of 52 on both sides, I'll just write this, this is really badly written, but this is going to cancel out these cosines, so I'm going to be left with A over here, that's what I want to know, which is the hypotenuse, and I'm going to have 3 over the cosine of 52. Now the key here is that I have to do the division I have to put 3 in first and then divide by the cosine of 52. So how I put this into my calculator is very important. So using my calculator here, now please watch this. I'm going to put 3 first. Then I'm going to hit the divide sign. I'm going to open up the bracket so that it now knows that I'm going to be doing another calculation. In this case, the 52 cosine. Close the bracket, then press the equal sign, and this will give me the value. Now this number, because it's the hypotenuse, must be bigger than the adjacent side of 3. And it is. It's 4.87 rounded to 2 decimals. So the answer here is 4.87, which makes sense because the hypotenuse must be bigger. And so I put that value in as the answer. Now the next question, it tells us we're going to use the tan function, but once again, if we did not know that, we can always figure this out by just looking at what we know. So I have my hypotenuse here, I have my opposite here, and I have my adjacent here. And the two things that I'm looking at here are my opposite and my adjacent. And in this case, I don't know the angle. So what I'm saying here is that tan of theta, that is theta, is going to be equal to opposite over adjacent, because once again, TOA says that it's opposite over adjacent. And so what we need to do to get this to be by itself is I need to take the inverse of tan. So in other words, I'm going to take 4 over 4 and then use the inverse of tan to get this answer. So basically, when I do the inverse of tan, I'm just going to have tan by itself over here, and I'm going to have 4 divided by 4, and then I'm going to take the inverse, so that's tan, and then it's the -1 there. So let's put this in the calculator to see what this looks like. So basically we have here 4 divided by 4, and obviously that's going to be 1 in this case, and then I'm going to take the inverse, or the second function of tan, so tan -1, and the answer to this is a 45-degree angle, which makes sense because these are both the exact same size, and 45 and 45 degrees is going to then, with added to 90 degrees, makes the 180 for this triangle. So when we put this in here, we would put our answer as 45 degrees, and that would be our correct answer. So once again, this time we are asked to find the unknown side length, but we aren't told which trig function to use. So once again, we just need to identify what we know. So we know that this is the hypotenuse. We know that this opposite side here is here, and that what we're actually dealing with here is we're dealing with adjacent and hypotenuse. So the adjacent and hypotenuse is the cosine function because of, sorry, not a, ka. And so what we would do is we would put cosine of 65 degrees is equal to, and I'm going to have my adjacent, which I don't know, and I'll call that f, over my hypotenuse, which is 9. Now this one's a fairly easy one because I just simply need to get 9 by or f by itself. I just need to multiply both these sides by 9. This cancels the 9s out here, so I'm left with f by itself all over there. And so it's just 9 times cosine of 65, which will be my what I need to plug into my calculator. So in here, I can plug in the 65-degree cosine first, and then multiply by 9 to get my answer. Now, once again, this is the adjacent side, which must be shorter than the 9 that is the hypotenuse. And this is shorter than 9, it's 3.80, so that makes sense. So if I plug this into the question here, I'm looking for 3.80, which is right there. There's my answer. So same idea here. I don't know which trig function I'm supposed to use, but I can identify that by, once again, finding out that this is the hypotenuse, identifying what my opposite side is, which is right here, directly opposite the angle we know, and then my other one here is the adjacent. So in this case, the two that I'm dealing with is opposite and adjacent, and I don't really care about hypotenuse right now, so that would indicate that I'm using the tangent function, the TOA. And so I would put tan of 45 degrees is equal to, and once again, it's opposite over adjacent. So what I would write here is I'm going to write 4 over, and then I'll call this F for adjacent because that's what the side here is. And so this one's a little trickier because once again, to get F by itself, I can multiply both sides by F first, right? But then when I do that, I still don't have F by itself because I have tan over here. So once again, these F's cancel out, so I'm left with 4 over here. But now I need to get this by itself, so I need to divide both sides by tan of 45. So I need to divide both sides by tan of 45. So we're going to have 4 over tan of 45 here. I'm writing this quickly because I have a lot to write. But basically, these will cancel out, right? So I'm left with F over on this side. And then I have 4 over tan of 45, which is what I have to figure out. So once again, this is a little bit different when we're plugging this in the calculator. We have to put the 4 in first and then divide. So what this looks like in the calculator is I need to go 4 divided by, and then I'm going to open the bracket and put 45 and then hit the tan sign, and then I'm going to close the bracket and then I hit equals. And so this answer, because it's 45 degrees, is actually 4 for the adjacent side as well. It looks very similar to that angles question we had just earlier. So it's the same sort of question, just now we didn't know the side length. So it's 4 is the correct answer here. Now let's take a look at this question here. So this one, we need to know the side length, and we are, in this case, this is the hypotenuse, and opposite of this is, this angle is opposite, and this is adjacent. So we are dealing with the adjacent over hypotenuse in this case, and so that would be ka, which is cosine, which is adjacent over opposite, and so I would write this up as cosine of 58 degrees is equal to, and I would put, and I'll call this A, because that's what they're calling it here, adjacent over 2 for the hypotenuse. Now once again, to get this by itself, all I need to do is multiply both sides by 2. This will cancel out the 2 here, and I'm left with A is going to be equal to 2 times cosine of 58. So what I need to do in there is just simply plug in the 58 cosine, and then times it by 2. And once again, this number makes sense because it's less than 2, because it has to be less than the hypotenuse length, that is 2. So rounded to 2 decimals, this is 1.06. And so this is why when I come in here, I want to choose this value here, 1.06. So taking a look at the next question, we need to then identify here what we do know, which is the hypotenuse, and we do know the opposite. So opposite over hypotenuse is sine, and we want to know the angle. So we don't know the angle theta, but it's going to be the opposite over the hypotenuse. So once again, to get theta by itself, we need to take the opposite over hypotenuse and multiply it, or take it to by the sine inverse. So that's sine of -1. So the way we do this is when we plug this into our calculator, we are going to go 20 divided by, so 20, which is opposite, divided by the hypotenuse, and take that number and then hit the inverse or the second function button and hit the sine function. And so this tells us that the degree is 53.13 degrees. And so that's why we would be choosing this value, 53.13 degrees, as the answer. So same thing here. We are looking for the angle, and once again, we have, in this case, hypotenuse here. We have our opposite here, and we have our adjacent here. So the two values that we know are adjacent and opposite. So that yells to us that we need to use the tangent function, because TOA tells us we need to use the tangent function. So this is going to be tan theta over, and it's opposite, which is 40, over adjacent, which is 9. So once again, we would be, to figure out theta, we simply go 40 over 9, and then we take the inverse function of tan. So that's the tan inverse. That's really badly written, but hopefully you can see what I'm writing there. So putting this into the calculator, excuse me, we are going to take opposite, which is 40, over adjacent, which is 9, to give us this value, and then we take the inverse function of tan, and so we end up with a value of 77.3, and then rounded up is 77.32 degrees. And so if I come back here, that is why we would be choosing this value here. So let's take a look at one last angle question here. So in this case here, we have the hypotenuse. And in this case here, we have opposite. And then this is the adjacent. So the two side lengths we know are adjacent and hypotenuse, which tells us we need to use the cosine function. So ka tells us that. So we were going to be taking cosine of theta, which is equal to, and it's adjacent, so that's 16 over 34. And so we would have to figure out theta, take 16 over 34, 16 divided by 34, and then take the inverse cosine. So once again, in our calculator, how do we plug that in? Well, we are going to take 16, which is the adjacent, divided by the hypotenuse, which is 34, and then take the inverse function of the cosine, and we are going to arrive at a value of 61.93 when we round up, so 61.93 degrees. And that is why when we come back here, we're going to choose this value here. Now, the last two questions are dealing with elevation and depression. So once again, these are long questions per se, but don't get too caught up in all of this wording. Just focus your attention on the actual diagram, which is the same as what we've been solving so far. But I'll read this question here as it says. It says the angle of depression from Ed to the ship is 44 degrees. The height of the cliff is 54 meters above sea level. How far out to the sea is the ship? And we're trying to find this x to the nearest meter. So what we're looking at here once again is this is the hypotenuse. This is the opposite. And so therefore, this is the adjacent. So the two side lengths we're dealing with is opposite and adjacent. So this tells us that we're dealing with tangent. And so we have the tangent of 44 degrees. And this is going to be over, and once again, it's opposite over adjacent. So this is 54 over, and we'll call this x, the adjacent. And so to get x by itself, what we need to do is we need to multiply by x both sides. So I'm going to multiply by x both sides. So this is going to cancel out this x here. I'm going to have 54 on this side. But then to get x by itself here, I still have to divide both sides by tan of 44. And that is why, when it's all said and done, we are going to need to have 54 divided by tan of 44. So what this looks like, once again, is this is going to cancel out the tans of 44. So we have x down here, which is the adjacent side, and it's going to be determined by taking 54 and then firstly dividing after that, and then by the tan of 44 degrees. And so plugging this into the calculator, this will look like this. So I'm going to have to take 54, divide it, then open the bracket, and then I'm going to use the 44 degrees, take the tan function, so 44 tan, close the bracket, and then hit the equal sign. Now what I end up with is a value of 55.91, which rounded up to the nearest meter would be 56 meters. And therefore, that is why I would be choosing this value here as my answer. Now let's take a look at the last question, which is also, in this case, an elevation question. So once again, it says the angle of elevation from Ed to the top of the tree is 52 degrees. The horizontal distance between Ed and the tree is 16 meters. What is the height of the tree? Well, we have this wonderful diagram. So what we can see here is that this is going to be the hypotenuse side. This is the opposite side. And this is the adjacent side to this angle we have. Now, once again, we want to know the opposite side, and we know the adjacent side. So this is, once again, a tan question. So this is tan of 52 degrees. And now, in this case here, what I know is I know adjacent. So it's opposite, which I don't know. So opposite is x. I'm going to put that at the top, over adjacent, which is 16. So in this case, to get x by itself, I can just simply multiply both sides by 16. So I multiply both sides by 16. And this cancels out here. And so what I'm left with is 16 times tan of 52 degrees is equal to x. And so when I plug that into my calculator, what that will look like is I'm going to take 52 tan, and I'm going to multiply that by 16. And so I end up with a value of 20.47, which when rounded down in this case is going to be 20 meters. And so that's why the answer to this question is going to be 20 meters. So what you would do after you finished all 18 questions, you click submit. And then it's going to, if you click on view score here, it will show you what your score is. In my case, wow, I got 18 out of 18. But it will also, if you had gotten a wrong question down here, it will give you some feedback, letting you know how you would have gotten the correct answer. So hopefully that all makes sense. Thanks for watching. And once again, please work over this. And if you have any questions, do not hesitate to email. Thanks for watching.